right, guys, it's show time. That's right, it's time to show me what you can do. These are example problems that will be on the quiz tomorrow. So, starting with number one, pause the player, solve it with the standard algorithm. That's important. And then when you're through, come back and see the solution. All right, the first thing, we're going to make sure when we use the standard algorithm that we line up our place values. So I'm first going to write my first number, 64,436. We're subtracting 6,000. So make sure I put that in the thousands place. 5 hundreds, 4 tens, and 6 ones. All right. We begin with the ones. So we're going to start right here with the ones. So I have 6 ones minus 6 more ones. So 6 minus 6, that's easy enough, 0 ones. Now I'm going to go to my tens. My tens. I have 4 tens to subtract from 3 tens. Well, I know that I can take 4 from 3. So my 3 tens need some help. I'm going to go to the hundreds. I'm going to grab one of those hundreds. That leaves 3 hundreds left. That 100 equals 10 tens. So 10 tens plus the 3 tens I now have 13 tens here. 13 tens minus 4 tens is 9 tens. Now I go to my hundreds place. In my hundreds place, I have 3 hundreds now, but I'm trying to take away 5 hundreds. So I can't do that, so I'm going to go to the thousands. If I grab 1,000, that leaves 3 thousands left. But that 1,000 equals 10 100s. 10 100s plus 3 hundreds equals 13 hundreds. 13 hundreds minus 5 hundreds is 8 hundreds. I go to my thousands place. I have 3,000, but I'm trying to subtract 6,000. I don't have enough, so I go to my 10,000s. I grab one 10,000, and if I take that one group of 10,000 and break it into 1,000s, then I get 10 of them, and 10 1,000s plus 3 1,000s is 13 thousands, and 13 thousands minus 6 thousands is 7 thousands. And I don't want to forget my 5 10,000s over here, and 5 10,000s minus no 10,000s is 5 10,000s. Make sure I put my comma in the right place. I go 1, 2, 3 over comma. So the difference of these two is 57,890. Going on. Next one, pause it, or actually pause it just for a second and do this mentally if you can. You should be able to. All right, let's take a look. This is multiplying with a multiple of 10. I'm jumping for joy because I can multiply by multiples of 10 very easily. I want to look at this just like I'm doing 6 times 3. I know 6 times 3 is 18. So therefore, multiplying by 60, 60 is 10 times the amount of 6. So 60 times 3 would be 180. All right? Moving on. Again, read the problem, pause it, solve it. Go talk on that moto, chat it up, see if you compare your answers with others, and then come back. All right, so Nisha had 27 quarters. 27 quarters. And we want to know how many dollars that is. Well, I know that it takes 4 quarters to equal $1. Equals $1. So every time I can group 4 quarters, then I know that I make $1. So I'm splitting up 27. So if I wanted to write an equation, I'm going to take those 27 quarters and group them in groups of 4 and that will tell me how many dollars I have. So, if I want to, one way I can do that is the forgiving method. I want to think how many groups of 4 I can make from 27. I know that 4 times 6 is 24, 4 times 7 is 28. I don't have enough. So I can do 6 groups of 4 quarters, which is 24 quarters used up. That leaves 3 quarters left. So I can't make another dollar with that. So this is my number of dollars. So Misha was able to make $6 and had 3 quarters left over. So if you wanted to know the exact amount she had $6.75. But let's go back to the question. It said how many dollars did she have? So we wanted to ask that. She had $6. All right, moving on. So it's just going to be quick. All right, quickly look at this. See if you can use your multiplication facts to reverse this instead of saying 44 divided by 4. 4 times what is 44? All right, if you know your facts, you know this should be 11. 4 times 11 is equal to 44. Moving on. Read this, pause it, solve it, then come back and see the solution. All right, anytime that you have a lot of information, especially when buying things, it's always good to draw those out and simple. So I know that she bought 3 basketballs, and each one of those was $6. So 1 basketball, 2 basketballs, 3 basketballs, and I know each one of those cost $6 or $6. Okay. She also bought a goal. Okay, and I'm going to draw the goal like this with a little net. It's not very fancy, but that's the goal, and that costs $7.99. So these are all the items that she bought. Okay? It also said that she gave the clerk 3 $10 bills. So if we're looking over here, this is what she bought. And then if she gave her 3 $10 bills, I know that's 3 times 10, which she gave the clerk $30. Very important. We are looking for how much change. So in order to find the change, we need to know how much did everything cost. Okay, and then we subtract that amount from what she gave the clerk. So I can see this is simple enough here, 3 6s. So I know 3 times 6 is $18. And then one goal of $7.99, and together that's my total cost. So this is easy addition. 8 plus 7 is 15. Regroup, that makes another 10. So she spent $25.99. So in order to see how much she got back, we know that we have to take our $30, subtract $25.99. Now, if you look at that, since $25.99 is so close to 26, it's only a penny away. So what if we subtracted $30 from $26? So if we're thinking $30 minus 26, we only know that that ends up with $4, correct? Get a little more room. So if I think of $30 minus $26, I know that that is $4. Well, I know that $26 was 1 penny too much that I subtracted out, so I need to add that back in. So therefore, I can adjust this, and I know my answer would be $4.01. But if you want to go through the long regrouping for this, we can do that. We're going to need to go all the way over here to the tens. If I take 1 10 and break it into ones, I get 10 ones. If I take $1, I get 9 left there, but now I get 10 dimes for that $1. I still need to hold the penny, so now if I take a dime, I have 9 dimes left and 10 pennies. So now I can do the subtraction. 10 minus 9, 1. 9 minus 9, 0. 9 minus 5, 4. And of course, 2 minus 2, 0. Still get $4.01 as the change. Okay, moving on. Read, understand, make a plan, do it, look back, make sure it's reasonable, you answer the question, and then pause it and come back to it and see what you got. All right. In this, we see that I bought some packages of brownie. I bought 16 packages, and each package has 14 brownies in it. So if I drew 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's my 16 packages, and every one has 14. 14, 14, 14, 14, 14, 14, 14, 14, 14, 14, 14, 14, and you get the idea. There's lots of brownies here. Okay. So lots of brownies. So how are we going to count that? We can see automatically that if I'm combining all these same amounts, this is 16 groups of 14. Right? So one of our strategies is break apart. So let's take a look. I'm going to break apart the 14 into 10 plus 4. So therefore, if I multiply 10 groups of 16, that's easy enough. That's 160 brownies. And then multiply 4 more groups of 16. Okay. Now this is a little harder, but again, if you think of this, we can think of this as 10 plus 6 more. So 4 times 10 is 40, and 4 times 6 is 24, and 40 and 24 is 64. These are both my partial products, so I'm going to add those together. 4 ones, 12 tens, makes another 100 there. So I bought 224 brownies. Now that's not the only way. You could have broken it up in a different way. But the main thing is that you count all the parts of each place value as you multiply these numbers. Okay, let's keep moving. All right, estimate, then find the exact sum, pause it, solve it, and then come back. All right, let's take a look at the estimate first. So what is this close to? Is this closer to 800 or 700? I hope you said 800, of course. And then 596, is that closer to 500 or 600? I hope you said 600. So 800 plus 600, my estimate is equal to 1,400. So if my exact answer is not close to that, then I know something is wrong. So again, if I'm doing this traditional algorithm, which I hope you used, get some practice. We line up all our place values. We'll add our ones. 6 ones plus 4 ones is 10 ones. Well, 10 ones makes 110, and that will leave me no ones left in my ones place. So I have 9 tens plus 6 tens plus 1 10. I can see automatically that 9 and 1 makes 10, and 6 makes 16 tens. Well, 16 tens makes 100, because 10 tens makes 100, and that leaves 6 tens in the tens place. So now I have 700s, 500s, and 100s, and together that's 1,300. So if I look, 1,360 is my exact, and it is close to my estimate. All right, moving on. What is the value of the 6 in this number? So I need to find where that 6 is. Use use the place value wrap if you don't know, and count them out. So starting over here, we don't have any decimals, so we'll just count ones, tens, hundreds, comma, thousands, 10,000s, 100,000s. So that tells me I have 600, 100,000s. So how do I write that? That is 600,000. because it is in the hundred thousands place. All right, moving on. Write the, oh wow, write the numeral. That sure is not right, is it? I made a DOL error. This should say numeral. Write the numeral for 4,306,059. Write that and then come back and check it. Well, you already see that I have commas in here for you. So, 4 million. Well, that's easy enough. There's only one digit in the millions, period. 4 million, so that would go in the last. Right here, it says I have 306,000. So that would be 306. Just like we would write the name without it. We're going to put it in between those next two commas. And then 59. 59 doesn't include any hundreds, but we know the last three places is hundreds, tens, ones. So remember, in the place value round, zeros hold the empty places. Well, we don't have any hundreds, but we have 59. So 5 tens and 9 ones. So in order to get a better look at this, let's look if I wrote it a little better than that. 4 million, comma, 306,059. That zero is important right there because I said no hundreds for those ones, period. All right. Good luck tomorrow. Chat it up on Edmodo. If you have a problem, you can send me a message through there if you can't answer it through your friends. Good luck. You're going to do great.